Looking at dividing with radicals, we're going to be doing something very similar to what we've been doing before, such as associating these radical expressions to each other, looking for perfect squares underneath these radicals. The first thing that we need to know is that the denominator cannot be irrational. We need to make sure that our denominators are rational radicals or rational numbers. And to do this, we need to make sure that either we have perfect squares in the denominator or we have integers. We have our negative or positive whole numbers. So to start with, we're going to do number 1 here. And looking at number 1, we know that 27 can be the perfect square of 9, so root 9 times root 3. Because root 3 is going to be, this is all over root 6, because root 9 is a perfect square, we can keep this in the denominator. So we're going to have our 3 down here. With root 3 not being a perfect, or 3 not being a perfect square, we're going to have to make sure that this irrational radical is removed from the denominator. And to do this, we actually multiply both the numerator and denominator by the same quantity that we're trying to get rid of. So times root 3 times root 3. So we have our root 6 up here. See if I can fit in here, root 3 here. And then we continue forward. Now, as we talked about in prior lessons, whenever you multiply two radicals that are the exact same multiple on the inside, those radicals are canceled out. So root 3 times root 3 is just going to be 3. So we have our 3. Now we have another 3 down below because of the fact that it's root 3 squared. Up above, we now have root 6 times root 3, or in other words, root 18. And down below, we have 9. So again, if we take this, we could split up our 18 into another perfect square. So root 9 times root 2. Root 9 obviously is 3. Cancel this, put in 3. If we look at this carefully, we have root 2, 3, and then a 9 down below. We can simplify this by reducing. And this is going to look something like this. Cross out the 3, so I'm factoring by 3 here. We get a 1, 3, and now I have root 2 over 3. And as we look at this, we notice that there is no denominator that is an irrational value. It has a 3, which is a rational number. Looking at the second problem, we notice that it also has an irrational radical down below. To begin with, let's get rid of that irrational radical. So root 3 is going to be multiplied on top and bottom. I'm going to have root 3 times root 2. And now I'm going to have my 2, and I'm going to have my root 3 times root 3, or root 3 squared. That cancels to give me root 6 up above and 2 times 3 down below. If I simplify this, I have root 6 over 6. And again, we have a rational number as our denominator, and it does not matter if we have an irrational number in our numerator. So we are done. We cannot simplify or reduce, pull out a perfect square that's going to be underneath the radical from root 6. It is irrational. Looking down at this last problem, we have two groups of radicals. We have one that's over quite a bit. As a first step, I want to make sure that I'm taking out everything that's possible from underneath that radical that is a perfect square, so that I'm not tempted to multiply it and put it up into my numerator without meaning to, or without needing to. So let's take a look here. I have 2 that are over the squared root at this point. Okay, and in here I have 1 that is over the squared root. So I'm going to rewrite this just by taking those out. So x squared is going to just be x, and y cubed is going to be y squared times just 1y. So the y squared is going to give me a y on the outside, but it's going to leave behind one of the y's to make that cubed. So I have 3y left in here. This is going to be over 4, which is already on the outside. And this y cubed again is going to produce a y squared times y. That y squared can be rooted and give me y. And I'm going to be left with 5y x. And it doesn't really matter the order if I put x first or y first, but because I was factoring out the y, I wanted to make that come out. I wanted to get that perfect square out first, so I put the y in first. Alright, so now I have all of this underneath the radical 5yx. Cannot have, even if those numbers give me a perfect square, I don't know that for sure the way that they're written. They're unknowns. And so with that, I'm going to multiply everything by that radical. So 5xy over 5 root 5xy actually. And I'm going to be given x, y, and underneath here I'm going to have 3 times 5 times x times y squared. Because remember, I have two y's from the very first point. So I have this first y, and then now I'm multiplying a second y there. Underneath, I'm going to have now 4y, which was there already. And because I have 5xy, root 5xy, times root 5xy, I'm going to have just times 5xy. Now I'm getting a little bit out of space, so I'm going to get rid of some information here. Let's see if I can make some more space here. We'll just change colors. So as you're looking at this, one of the things you might notice is there's some really easy ways of simplifying the ones that I have left. So we'll just kind of move up here. I have my xy on the outside, and then I have this y squared on the inside. 3 and 5 both are prime. They're not going to give me any perfect squares by multiplying them together that I could draw out as a factor. So I'm going to be able to just multiply those together. X is all by itself, and so with it being all by itself, it's also not going to be able to be rooted evenly. And then I have this nice new multiple down here without any radical signs. So let's see how it looks all together. So I have another y out, so now I have y squared, and then whatever's left inside. So 15, and then that x. Over, and now I have this 4 times 5, 20, y times y, y squared, times x. And I'm done. However, I can still factor more. And by factoring, I mean by reducing. So if we look up into the numerator, I'm going to be able to see that I have some values that are the same. I have an x and an x down below, so those cross out. I have a y squared and a y squared, both on top and bottom, so those are going to cancel out. So what I'm left with is my radical up on top, root 15x, and my rational number of 20 down below. So my final answer here is the root of 15x over 20. And we usually put like a little downward mark here just to show that that's the last little bit that's included in our radical. So there is our final answer. If you have any questions, bring them to class tomorrow.